I know I'm between you and lunch, so sorry. I head identity and access management in UBS, one of the Swiss banks, big in wealth management. And I want to give you our story about deploying Secure NFS in our organization. So, give some of the background why we're doing it, and then all our experience on the obstacles, what we've learned, maybe share some of it with you so you don't have to run into it. It's going to be very different from all the other talks I've seen so far. So not intrusion detection, not data leakage prevention. It is on the infrastructure side. A lot of this is Kerberos based, so that's all being engineered in my team. We have at UBS a large infrastructure of thousands of hosts, 10,000s of hosts, thousands of file shares, and I don't know, I expect you're sitting here, you know what NFS stands for. I've heard various abbreviations, no file security being one of them, no freaking security being another, and then there is no effing security where I can't really say in public what it means. We are aware in our infrastructure, been using NFS for years, for 20 years. It really was at the heart in how we've installed our applications, the OS on the disk, and then applications and all the data on NFS. So it's pervasive in the environment. It's running our applications from the front to the back office to trading. It is at the heart of our infrastructure. And yeah, no file security as it was developed. It was developed in the 80s by Sun. There was assumption of how an environment is trusted, super users are trusted, and you can trust the client to impersonate a user, and we know today impersonating users can't do that. So we tried in the early 2000s changing that and stopped again. So why did we start again? We're heavily regulated. Auditors coming in again and again and telling us what's wrong with our environment. A lot of time that's very painful, very annoying, because they're telling you what you already know and you haven't been able to do anything about for a long time, but you need to see the positive of it, work with them, enhance the environment, bring it forward. So really we consider them our friends as well from an infrastructure side, security side, because as engineers, we love to do that stuff, and the auditors, they definitely help us getting that stuff done. These are just a few of the international regulators that look at us, look at our books, tell us that we still have a banking license, being able to trade, work with customers. So they told us again that sys, which is what everyone is using in NFS, is no good because the client can say this is the user that is logged in, he wants to access a file, the file server accepts that and takes at face value who the user is. There is no authentication, really identifying the user over the network. That is okay-ish in corporate networks back in the 80s, 90s. Today's the insider threat that is no longer really permissible. And there are more than NFS as a network file system. So yeah, NFS is network file system, sorry. There's the Windows SMB, there is Andrew file system, AFS, Hadoop nowadays. So we looked at all of them when they told us NFS is not secure, you need to secure it, we should pick any one of the options. And interestingly enough, all those options have one thing in common. Even though, yeah, one is Windows dominant, one is Unix dominant, one was really developed in a niche Andrew file system, heavily deployed at another large bank, Hadoop, they all authenticate the user using Kerberos as the underlying security protocol, all of them. And that really is the challenge. We have 3 years ago now deployed it, and I'll talk a bit about all the details. So right now, we're a fair way in, have a lot of experience with it. It's on thousands of hosts, thousands of user home directories, hundreds of applications are using Secure NFS now at UBS. It's, as far as I know, one of the largest users of Secure NFS. I've not seen it anywhere else that pervasive. And what helped us in deploying it was that when we looked at it in 2000, 15 years ago, we started deploying Kerberos. And when we looked at all those options, which file system should we use to secure? Should we switch away from NFS? It was like, no, we'll keep with NFS. It's the file system in the Unix space that is most pervasive. The problems really are all around Kerberos and using Kerberos at a large scale. And it's not only Kerberos, it's also user identities. You need to have user identities centralized, whether that is with LDAP. A lot of people now, as they deploy a new, choose Active Directory, because Active Directory is just a combination of LDAP and Kerberos. In our not-so-greenfield environment, and because in 2000 we did deploy Kerberos, we just stuck to the Unix environment being Kerberos and LDAP, and not integrate into Active Directory. Anyone who's doing it today, the environment has moved on so much, I would expect a lot of people really go and look at getting Kerberos from Active Directory, even if that pains a Unix person, to use Microsoft as the central infrastructure to authenticate users. It is come a long way, and the Unix integration into Active Directory is really, really good these days. And it's the one thing that any organization focuses on, getting Active Directory properly managed. And if you'd have to do it all over again in the Unix space, it's a lot of work. As we went on using our Kerberos infrastructure to deploy it, one thing is you need to tell when you're mounting a file system, use Secure NFS, sec equals KRB5, and that's really annoying. Why can the protocol not figure that out? Sun actually in Solaris did that again 20 years ago. Red Hat doesn't, certainly not with NFS version 3. We also looked at NFS version 4, and I can, if you're interested, give us some of our experiences with NFS version 4. We didn't end up using it. It was still not ready, in our view. But NFS version 4 has in the protocol security negotiation in there, so that you can just mount something and it will figure out under the hood whether it should be using Secure NFS or not. Only it's in the protocol specification. When we started doing it, it was not implemented in Red Hat Linux. We went back to them, and it's now implemented. So as of, and that's now 3 years ago that they did that, RHEL 6.4 security negotiation is in the protocol, but it then didn't work with our NFS service, which are all NetApp filers. They had implemented it so that it was working with Solaris because that was the only thing they could test. They could never test with Linux because there wasn't an implementation. Now that there is one, that didn't interoperate. Again, some years on, it is now working, and the latest version of ONTAP supports that security negotiation in NFS version 4. So if you're deploying it, then you don't need to separately specify, because with our thousands of shares, you don't know when you look at a share, is it Secure NFS or not? You need to ask someone so you can mount it correctly, and that really is not very helpful. Also, when we started, filers, they were really ancient, and I don't know whether you know that, and it shames me to say it in front of this audience. That was 3 years ago on Tab 7, the only cipher it supported to do Secure NFS. Was not worthy of the name. All they did was DES, which even at that time was long known to be deprecated in all other Kerberos installations. Again, we're now on those years, and NetApp has their new versions, and it supports AES 2.6, so finally we can deploy it in a way where, yes, actually Secure NFS is worthy of the name Secure. Only when you start doing that, you then realize that some of the older clients you have, because in a large infrastructure there's always out-of-date clients, old ones, that they don't support it. So, still, we're there now. It is a lot of work, but if you're trying to do it now, news is good. The next one I want to highlight is GSSD. I don't know whether you know enough about Kerberos and how it works with when you authenticate, you get a ticket granting ticket, which you then use as you want to authenticate against further services, be it logging into a host with SSH, using it for HTTP authentication, using it for NFS authentication. You go get a service ticket and you use the service ticket to then access the service. And your ticket granting ticket, as you log on to our Unix system, is stored in the temp directory. And as you log on with SSH, it chooses a random name to store your credentials. Again, if you would have a fixed name in the temp directory, it would open you against denial of service attacks where someone can create a file with that known name and you can't log in. So choosing a random name protects that, but then when the call from the kernel comes into the user land, I need to establish a secure connection. Can you please get me the credentials? RPC-GSSD, which is doing that work, scans over the temp directory, all the files that may be in there, thousands sometimes, trying to find your valid credential cache. And you may have more than one. So the first implementations of RPC-GSSD just took the latest timestamp credential cache, the most recent, assuming that the credentials inside are also the most recent. Not necessarily so. So again, that was 3 years ago when we first did it. Now that has changed. It looks inside and checks whether the credentials are valid and then takes the credential cache with valid credentials. I don't even go into the access as root. That was with RHEL 5 that it was a problem. With RHEL 6 or RHEL 7, that's no longer a problem, so probably not worth mentioning, but yeah. RHEL 5 and access as root, don't try to do it, it can't. And really, you shouldn't. So as I said, we have the users, we have the applications. As we deploy it and move all the user home directories over to Secure NFS. The story there, users adapt. Migrating user home directories was surprisingly easy. Yes, they all complain because your credential cache is short-lived, works for a day. Most of the people at the end of the day lock their computer, next day they unlock, still accessing all their sessions they had to the Unix hosts, and then their credential cache expired, they can't access their home directory anymore, they need to refresh the credentials. They complain the first week that they've been migrated, and then they stop. They get used to it. And you do the first wave, the first 100, the next 100, and once you buy 1,000, word spreads, they find, not workarounds, but there's utilities, K-renew, which you can point at your credential cache, because the credential cache, why it is restricted to a day, depending on your policies, quite often 10 hours. Quite often it has a renew lifetime of a week. So you can keep on renewing it automatically with K-renew for a week, so you only have to log in on a Monday morning, and the rest of the week it's okay. They learn that, they share that, and yeah, we have 10,000 users on Secure NFS. more than. And I don't hear a single complaint anymore. And something when we started, I didn't quite believe we would ever get that far, but that was easy. What was not so easy is applications. So as I said, we also run applications of NFS, and we have a lot of data, shared data for applications on NFS. I picked here some, not quite random. We use those within UBS, but obviously we write our own applications and they're not reflected here. They also use NFS. How do you give an application credentials to authenticate? Applications never log in, they just start. That is the challenge. So no one typing a password. And when you go from one host to another, how do you authenticate an application going from one place to another, SSH keys? None of that unlocks Kerberos credentials. And as it's Unix, there's way too many ways on how to solve that problem. Again, it pains me because I come background from Unix, but in the Microsoft world, as you install an application and you start it under a service account, you provide all the application login service account credentials and it sets everything up. It starts the security context for the application. The application can use Kerberos authentication, GSS API authentication to a database, to a web service. It's all there, the infrastructure in the OS and how to do it. Not so in Unix. There's just more than one way to do it and no uniform way across all the different Unix flavors. Again, we looked at all those different options. One of them is you put a key tab onto the host. Key tab basically at its heart is a password that you can then use to authenticate to the KDC to get your ticket granting ticket, your credential cache. And you need to keep on refreshing that because for the applications as well, it times out. So how do you refresh the credential cache from the key tab? You use cron. You use a utility kstart, which comes along with krenew. You use cron on steroids, autosys, or any of the other scheduling systems. Do you tell the applications to write that into their code to do that again and again? You do it in the pluggable authentication modules as applications get started up. That's the way that Sun is choosing to do it. Oracle is now choosing to do it in Solaris. Or do you use GSS proxy, which is what's coming in RHEL 7, or has arrived with RHEL 7. Or do you use something completely different? So Karen is a tool set that was written at another large bank and has been open sourced, where you do not store any permanent credentials for an application on the host, but rather you use the host identity and you enable the host identity to get a credential cache on behalf of the application running on the host. Very clever. And you don't ever have a long living secret on the host. The key tab is a long living secret. It's something, once you deploy that onto the host, you need to keep on changing. Because if someone grabs that key tab, walks away with it, they have the secret that they can use somewhere else to impersonate the service account. Or do you use S4U, which is an extension in the Kerberos protocol? Not sure whether you come across it, service for user. It's Microsoft is championing that as well, where again, within the Kerberos protocol, you allow the host to impersonate other accounts. Very powerful, possibly too powerful. So we ended up choosing the first key tab way and then all the pain that comes on deploying it because, as I said, we have thousands of hosts, hundreds, thousands of applications. If you multiply that, that's hundreds, thousands of key tabs that you need to deploy across the infrastructure and then keep on refreshing them. So we wrote our own ways on how to do that, and then we used kstart as a process that runs on every host and from the key tab keeps on refreshing the credential cache. Problem there is if KStart then dies, credential cache doesn't get refreshed, application cannot access the file system anymore, and it falls over. It's fairly stable, doesn't happen a lot, but GSS proxy in RHEL 7 really is where I think everyone should be going. When the up call comes from the kernel, there's an NFS call, I need a security contact for that user, it goes into user land, it will automatically, during that call, go look for the key tab, make sure the credential cache is up to date, refresh if required. Well, I will first check whether it needs to refresh, and then it will go for the key tab. The advantage there even is that because GSS proxy runs in the OS context and doesn't run as the user like KStart does, you can then hide the key tab away, the long-living secret. And the user never gets to it, no one can go and steal it. The only thing that is exposed to the application is the short-lived credential cache. We do a lot of certificate authentication in our environment as well, and with certificate authentication you always have a private key, which you need to keep on renewing, and it is the secret. If someone walks away with it, they can, for a year, 2 years, however long you use your lifetime on a certificate, keep on using it. GSS proxy and key tabs hidden away, the only thing someone can walk away with is a credential cache that's maybe worth 10 hours, 24 hours. It really limits the attack vector that you expose yourself to. I'm ever so glad that came with RHEL 7, but I don't know if anyone's using it and you found other ways to do it. I'd be very interested to hear. Because for me, that particular one, even with GSS proxy, you still have the nightmare of deploying key tabs, renewing key tabs. That where Karen is really nice. You only have one, and then you don't need to deal with any other key tab and refreshing them. That is the biggest crux. How to authenticate applications. But we've managed, it's stable. As I said, we have hundreds, thousands of applications, now also running with Secure NFS. Oops, that was the wrong button. If I summarize where we're at, and if people ask me about Secure NFS, absolutely use it. It works. NFS 4, because you may have noticed securing, there's authentication. But authentication is no good. Alone doesn't solve security. You always need authorization as well. And if you're aware, Unix, all you have in file system permission is user group others. That's not very powerful if you want to authorize access to a file. It's very rudimentary. NFS version 4 brings access control lists, and you can a lot more fine granular control than access. Whether that is asking for the devil, because most of the people in our infrastructure, they already don't understand user group others and chmod, and then trying to inflict access control lists on them, chaos. So again, you need to then invest a lot of time on how do we structure this, how do we help the users to keep the environment secure, because if they don't understand it, automatically environment will again be opened up, because that's normally what the user does. Can't access it, doesn't work, okay, chmod 777. And you don't want to be there again, right? And all the authentication doesn't help. If it's world readable, world writable, the fact that the user who just changed your data, deleted the file, it doesn't matter, it's gone. So NFS version 4 needs to come into it as well, and we're over there, a booth, UBS. If you want to know my experience, our experience about NFS version 4, come have a chat. Come have a chat with us anyway. There's loads more that we can tell you about what we're doing in UBS. It's not just the infrastructure side and security. I'm always very proud to talk about this card here that we do, which everyone uses to log in. It's got 3 computers in one, so come over, talk to us, and I'll tell you all about it. Here, if you want to do Secure NFS, do it with Active Directory if you don't have a Kerberos installation yet. That is the most important thing. The namespace to Kerberos. If you have that, you're golden. Use it, you can do it. Thank you very much. If you have any questions, let me know. Otherwise, lunch awaits you now. Yes? Triple SD, brilliant. Absolutely brilliant. Works wonderful with Kerberos, works wonderful with LDAP, all configured. That's how I would want it everywhere. Yeah, triple SD. What was the first one? No. I'll be interested to learn about that, but never used it. Okay. KCM, no.
I solved the issues with caches on /CMP.
Okay, cool. Thank you. Thank you very much. Lunch.